Greetings and welcome to Physics in the AM, continuing on with potential energy. Okay, as far as potential energy goes, there's all kinds of potential energy, chemical potential energy, etc. But we're going to focus on mechanical potential energy, and in particular, due to height differences. Okay, gravitational potential energy depends on your position above some reference point, usually the floor of the room or the Earth's surface. Okay. And that kind of potential energy is really easy to calculate, mgh. And g is positive 9.8. We're just using that. So the mass, the acceleration due to gravity on this planet, on average, and the height. So I got my 1 kilogram mass here, and I'm not going to drop it. But if I hold it, I use this as my 0 point. If I hold it 1 kilogram, 1 meter above, it's about 1 meter. Right now, if I dropped it, it has potential energy. I think you wouldn't argue on that, right? Okay. And it actually has 1 times 9.8 times 1. It has 9.8 joules of energy right now. That's how much work I did to lift it up there as well. You know what? Here's where it gets interesting eventually. I can drop this, and it's all going to convert to kinetic energy as it drops, right? We'll combine those two things later. Okay? Now this is how simple it is right here. 2 kilogram book lifted on the floor to a shelf 2.1 meters above the floor. What's the potential energy relative to the floor? So I can only do potential energy relative to the ground outside if I held it out the window. It would make sense. Okay. MGH. It's a really easy one. And the height. I'm going to have to use a calculator because I don't know that. 5, 9. Oh, I guess I should turn it on. Times 1.10. Okay, well, I get 41.16. I'm going to call it 41.2 for significant digit reason. That's joules. Okay. All of that. That's essentially the work I did by lifting it. If I lifted it from the floor. All of that, if I drop the book from that height, that's how much kinetic energy it'll have just as it kisses the floor, right? That's what's important. Now, what we're going to be doing is on the opposite side. Activity. As I mentioned, everything can be converted to potential energy. It doesn't matter the route, though. I could drop something straight down, or I could take a ramp or stairs, or on a pendulum, swinging. Let's compare the potential energy and the kinetic energy of a cart at the top and the bottom of a ramp. We're going to actually do this. We'll need to figure out how to set this up. Well, you've seen me do this. We've done this when we looked at acceleration, accelerated motion. And I think Josh's table works the best because it doesn't have any ledges underneath. We tip that upside down. Okay? We have spring scales to measure weight. Measure the height from the front of the cart to the floor. Find the kinetic energy of the cart using the speed of the cart at the bottom. So we're going to have to allow the cart to roll down the ramp and then measure the time needed to travel 1 meter along the floor. You guys follow what we're saying? It's going to be an average. It does slow down. We're going to use this cart here. It's a very simple calculation. This one's heavy enough this year. I don't think I need the 1 kilogram mass. Well, we can tape it on. Okay, cart and 1 kilogram mass. This height, you guys follow this? So it's 0 speed to start, let it go, boom. Then we'll measure the speed as it rolls along the floor, and we'll assume that was the speed, the average speed for that 1 meter. Okay, you guys get the idea here? Let's just do this. I'm going to stop recording. It's fairly simple.